Hello guys and welcome to today's video, and today we're going to be talking about the Big Bang Theory and how did the universe form in the first place. The beginning. So this person named Georges Lemaitre, and this person was a cosmologist which studies the universe, and he stated with a theory: if the universe is always getting bigger, then long ago it was smaller, and long ago it was much smaller. That means billions of years ago, everything in the universe was contained in a tiny ball that exploded. Wow, that's amazing. So, this idea of a tiny ball that's constantly exploding is known as the Big Bang. It's called the Big Bang Theory, and most scientists accept this theory as a fact of how the universe has become created, although it's still a theory and still needs scientific support behind it. So the Big Bang was the moment 13.8 billion years ago when the universe began as a tiny, dense fireball that exploded. Most astronomers use the Big Bang Theory to explain how the universe began, but again, what caused the explosion in the first place is still a mystery. That is why this remains as a theory. So the picture in the middle here, on the top right actually, is a picture of a Big Bang, and you can see the explosion and formation of galaxies, rocks, dusts, and everything began in the Big Bang. Now I'll show you guys a short video that simulates the explosion of the Big Bang, if you can see in the video here.
At Eversource, when a serious storm knocks out the power, we are there, working through the storm.
Okay, this is the simulation of a Big Bang. You can see the different galaxies and stars that are forming. Yeah, that was a really short but also really interesting video of how the Big Bang was done and how it was like exploded, and everything that's exploded was later formed into gas, and which was later combined into stars and galaxies, and you can see all those happening in the video. So again, what happened after the Big Bang? As I talked about before, the universe has been expanding ever since the Big Bang. In the early years, everything was made out of gas. This gas was hydrogen and helium gas, which expanded and cooled over time, and over billions of years, the gases were moving around. Then suddenly gravity pulled all of them in, and the dust to form many stars. So gravity is what makes the gas together, what keeps the gas together to form stars, as we know today. To form also galaxies, which are composed of stars that we see today. And we'll get into details about what stars are and what galaxies are in just a moment here. But the matter that spread out from the Big Bang developed into everything in the universe, including us, that we formed on Earth. So this is the basic outline of what happened after the Big Bang. So this event here on the left top here is the Big Bang. Everything exploded in a tiny dense ball. Then the universe began expanding, ever since, and made into a gaseous state, like here. And after that gaseous state of the universe, everything began to collapse and began to combine by the force of gravity into stars and galaxies and solar systems that we see today. So stars. I'll be talking about more what stars are in detail now. So what is a star? A star is a gas that is all held together by gravity. Again, gravity plays an important role here by keeping every gas in a star together. And stars are mostly gas. It's almost like entirely gas, but not all the time. But it is also a building block of the galaxy, and stars are huge and very bright. So they are so big and bright that we can see the stars extremely far away from Earth here with our bare eyes. Light and heat energy is mostly released by the star, and the star is constantly being made and destroyed, and this process takes millions and even trillions of years over the time period. And a most common star to us is known as the sun, which we can see just outside the window. And you can see how bright the sun is, how hot the sun is, despite the fact that it's really far away. So these are just the stars that we see on the night sky when we are outside, and the right picture here is a close-up picture of a star. So not to be mistaken with the sun is also a star, so that is why it looks, all the other suns may look similar to the sun, and there are different types of stars as well, but we'll not get into the details of what each star types will do, but just know that this is a type of a star that is just somewhere in the galaxy, and I'm not even sure if this is even close or far away from Earth, but this is just an example of what a star looks like. It's a gas that is all held together by gravity, that in a reaction in the sun or in other stars, they release heat energy and light energy, and just remember that is just the gas that is playing the role. So I'll talk about what happens when the stars are destroyed. When stars collapse, most of them return back into their gas states to form more stars millions of years later. However, when the stars collapse, when huge stars collapse, I'm not talking about the small stars like the sun. The sun is a small star, to surprise some of you guys. There are stars that are at least 100,000 times bigger than the sun. And those stars, when they collapse, they create what is called the black hole. When huge stars collapse, they condense and collapse into a single and tiny dense place. And that place is called a black hole, and that place is so dense that it has such an unimaginably immense gravity that even light cannot escape the black hole. So again, black hole is a tiny space that is created when huge stars collapse into a single point, and it is so dense that it has such great gravity. So that gravity again can pull stars in, it can pull light in, it can pull everything in basically. And they become bigger by consuming other stars, and that's what it looks like actually. If you can see in the picture here, this is an example of a black hole, and it's pulling other stars in. You can see on the close picture here, like when the stars get closer to the black hole, they began kind of stretching because the gravity is so big, it's so great, that when the stars, when they get close to the black hole, they become like a spaghetti noodle. That's what's called the spaghettification, which means that everything that goes near the black hole, across the event horizon, which is the space in the black hole, they become like really stretched, basically. Everything becomes really stretched because of its gravity. And they're all pulled into this single point. So right here is explicitly showing the black hole, the single point which has gravity, and around it is a huge area where it consumes the stars. And you can see how much this black hole has been consuming when it was created by determining how big it is. You can see the planets and stars, everything's being pulled in by the black hole. And this black hole is really huge, and even pulling millions of stars into the black hole. And the black holes get bigger and bigger every time it consumes a star and consumes other rocks, dust, and everything. Now that was black hole. And now we're getting into more of a collection of a star called a galaxy. So we'll talk about our galaxy too. So the formation of our galaxy. Our galaxy is called the Milky Way, and it is made out of many stars, planets, dusts, and gases bounded together by gravity. So all the galaxies are made out of millions and billions of stars that are just a collection. So our galaxy is called the Milky Way, but there are billions of galaxies out there. So the center of our galaxy is a black hole, which has the gravitational force to make the swirly shape of the galaxy. I'll show you guys later in a bit. But our galaxy is formed in a swirly shape, which is caused by the black hole. And astronomers identify large areas of space by galaxies, and there are possibly billions of galaxies in space, which is too many to count. And just recap here. I'll make sure you guys understand. Everything started from the Big Bang, and the Big Bang created dusts that are out in the space, and the dusts formed stars by gravitational force, and those stars, by millions of them, formed galaxies, which are a collection of stars, and sometimes other planets and dusts and stuff like that. And now, back to our galaxy. The center of a galaxy is made out of black hole, at least for what our Milky Way has to offer. So if you can see in the picture here, oh, this is just a picture of billions of galaxies. So each one of these swirly things that I talked about before, these swirly things, these spirals, are all galaxies, which are basically like combination of stars, planets, like I talked about before. And you can see there are billions of galaxies. This is just an imaginary picture of what space would look like, what the universe looks like. And inside here is, here, if we get a closer look at one of the galaxies here, this is our Milky Way galaxy, and the center is a black hole. And you might be wondering, where's the hole? It's just a blank, like, it's just an immense light that is collapsing into a single point. That's the whole purpose of the black hole. So the black hole, because it's so dense and so small that there exists a black hole, but everything, light is being pulled into the center. That's why it looks so bright in the center. It has a black hole that pulls all the light in, all the stars around it, basically. But if we get a closer look, what do we have here? Okay, so, well, first of all, let me explain what these arms are. So, astronomers identify these arms as a part of a galaxy, since one segment of this galaxy kind of looks like an arm, not gonna lie. But these arms are just named Perseus arm, Orion arm, Sagittarius arm. These are all just names that astronomers came up with, and just know that most of the galaxies and the star formations are derived from ancient Greek. So there are these myths that maybe a goddess or a god created these galaxies, so that's why some of these names may be weird. But if we actually see here, you are here, so there's a pointer here. It's pointing to this spot. I'm wondering if that's where Earth is, where our solar system is. So let's actually zoom in here. So we zoomed in, and our solar system is actually here on the galaxy, in the Milky Way galaxy, as it states. So most known exoplanets are, we expanded this way to explore different stars that are around our solar system. And this is our solar system. It's pretty far away from the black hole. And if we zoom in even further, this tiny white dot here, what is it? Click on that. Wow, this is our solar system. So the tiny white dot that we see here is, it was most likely the sun, since the sun is the biggest star that's in our galaxy, being that is in our galaxy, and every other planet's orbit around the sun, and this is our solar system. Now, that was a huge chunk, so I would like to probably recap with this video here, which kind of explains what I've talked about so far. Get a video loaded.
This year we're doubling down on new at Bob's.
I've got new styles, new mattresses, new motion color.
Okay, let's get into it.
The Big Bang Theory. For kids, have you ever looked up at a clear night sky and wondered where all the stars and planets came from? Same here. That's why we are talking about something called the Big Bang Theory today. It's one of the theories, or ideas, that scientists have accepted as a possible explanation for the creation of our vast universe. Ready to learn more? Let's jump into our imaginary spaceships and take a trip across the galaxy. Set the dial to the year 1927. The Big Bang Theory was first suggested by a cosmologist, which is someone who studies the universe. That person was a priest named George Lemaitre. He thought that a very, very long time ago, the universe started as a single point, then expanded and stretched to get as huge as it is now. He even suggested that the universe continues to grow, even today. To check out this theory, let's get back in our spaceship and travel even further back in time to beep boop 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 14 billion years ago. The Big Bang Theory represents the idea that the universe resulted from an explosion. As hard as it is to imagine, scientists believe the entire universe fit inside a bubble, thousands of times smaller than a pinhead. Wow, that's mind-boggling. In the beginning, the universe was made up of hot, tiny particles mixed with light and energy. As everything stretched and grew, things started cooling down. The tiny particles grouped together and formed atoms. Then atoms grouped together over lots of time. We are talking millions and billions of years. These groupings of atoms came together to form stars and galaxies. As these new stars were being born and dying off, other things like asteroids, comets, planets, and black holes began to form together through the force of gravity, which is why newly formed planets began to rotate around
That's our
their
solar
stars.
system right there.
Just like the planets in our solar system rotate around our sun. Oh my stars! Amazing! So, what about our solar system? Well, it was formed the same way, about 4 or 5 billion years ago. The Earth's sun, which is also a star, is about halfway through its current stable phase. Eventually, the sun will go through different phases and eventually die out, but not for another 5 billion years or so. Here's an interesting fact. The sun is just one star of more than about 100 billion stars in the Milky Way galaxy. And the Milky Way galaxy is just one of billions of galaxies. It's so hard to imagine. Today, scientists are constantly studying and observing space, seeking out farthest and oldest galaxies to understand the beginnings of the universe.
Yeah, that was basically a short recap so far of how from the Big Bang they formed a lot of gas and energy, and all those gas formed into a star, releasing the energy as heat and light energy. And from those stars there formed black holes and stuff like that, and those stars came together to form a galaxy. And inside a galaxy we have our solar system, which we will continue. So how did our solar system form? Well, not to get confused our solar system with the galaxy, so our solar system is just like planets that are orbiting around a single star, and galaxy is a collection of millions of stars. So basically our solar system is a small, I guess, a small way of like system inside a bigger system. So as you may know, the center of our solar system is called the sun. The formation of our solar system started with the sun's gravity, pulling in planets and rocks about 4.5 billion years ago. That's how old our solar system is. So those planets include, in order, Mercury, Venus, Earth, Mars, Jupiter, Saturn, Uranus, and Neptune. And Pluto, which was considered to be a planet, was expelled from the solar system a couple of years ago. And around, like, I think 6 or 8 years ago when that happened. And this is a closer look at our solar system with more details on it. So again, the sun, the closest to the sun is Mercury, and Venus and Earth where we live, and Earth is the third closest planet to the sun. And then it continues on to the Mars, to Jupiter, to Saturn, Uranus, and Neptune. So this is our solar system, and as you can see in the label here, the mass of the sun takes up 99.86% of the solar system. Wow, that's crazy, right? Since the sun the sun is like really big compared to the planets that we have in the solar system, and it's more dense and it compacts all the gases. So that is why the star takes up most of the mass and space in the solar system. So again, this is the accurate size comparison. So the Earth is quite small compared to Jupiter, and it's smaller than Saturn, it's smaller than Uranus, and it's a bit smaller than Neptune, but it's definitely bigger than Mars, Venus, and Mercury. But it does not compare to the Sun, which appears small from our perspective, but it's really big compared to Earth. You can see here. So now diving deeper into when the Earth was actually made. So after Earth first formed in our solar system, it was extremely hot and entirely liquid of magma. The Earth eventually cooled down, forming solids like continents and oceans as well. These pieces of land moved around the Earth's surface until it formed what it looks like today. And the most important resource was formed in the process, which was water, which scientists say sometimes is driven up from the Earth's core, and it is essential in the formation of life on Earth. While we are on that, we'll briefly talk about the life on Earth, and I'll cover more of the Earth and human evolution in our next class, but this is a brief overview of the basic outline of what life was on Earth. So the earliest life. The earliest life forms we know of were microscopic organisms, which are microbes that left signals of their presence in rocks about 3.7 billion years old. So our first present of life was 3.7 billion years old, which is a long time ago. And there are multiple theories on how it was made in the first place, some being the combination of different elements or arrival by the comet. So I have a picture here which shows a microbe, which is a microscopic organism, and as you might expect, these microbes are really small and can be only discovered by microscopes. And this is more of a close-up picture of what the microbes and microscopic organisms, which are often a single-celled organisms, look like. And you can see in the picture right here, this is an actual picture from a microscope, and this is what the microbes looks like. So this is what was first formed as a life on Earth. Now, more about the complex life. So how do these single-cell organisms become more complex life? Well, they began to group and cluster together, and they first formed multicellular organisms, which are living things with multiple cells. They could do a specific job, unlike a single-cell microbe that we talked about before. So these multicellular organisms plays a role in a community, and these kind of look like this, which is a combination of unicellular and microbes, which are combined to form multicellular, which is multiple cells organisms. And these play a more complex role, and these microbes and multicellular organisms later form out fish, animals, dinosaurs, and apes. So the apes, again, is an important role in forming a human, which I'll talk about that later too. And here the clusters of multicellular organisms later again formed animals like us, and many cells came together to form these complex forms of life on Earth, and eventually formed us humans. But it is still unclear on how these events happen. How do these single-celled, simple organisms become humans like us? Well, a theory arises from the scientists, and it's called the evolution theory, and it is raised by Darwin, and it is a complex yet still famous theory that we have today, explaining how a single-celled organism became a human. So this is the basic outline of human evolution. Again, we'll get into more detail on our next class, which is about human evolution. So we'll get into way more detail than this, but just know that first was a single-celled organism on Earth, and then developed into Homo sapiens, and there are a lot of process of humans as well, and you can see that they've developed from apes. And I have a video about the evolution theory, which explains Darwin's theory of evolution.
Charles Darwin was a famous scientist in the 1800s. He was famous because he came up with an idea that changed the way we think about life on Earth forever: the theory of evolution. Darwin loved animals and studied them all of his life. In 1831, he went on an exciting voyage aboard the ship HMS Beagle. The Beagle visited the coast and islands of South America and Australia, where Darwin observed and collected a wide range of weird and wonderful plants and animals. When he got back to England, he analysed his collection closely. That was when his ideas about evolution started to form. Darwin had found around 15 different species of finch when he was on the Galapagos Islands. He noticed that the birds were similar to other finches in lots of ways, but their beaks were all different shapes. Darwin looked into it further. He realised that the different beaks matched the type of food available on each island. The finches who ate insects had skinny, pointed beaks, so they could pick them up better, and those that ate hard fruits had beaks that were sharp, so they could get through the skin. Darwin decided that there was only one way that this could have happened. The birds must have adapted to their environment over time. This led into another idea, which he called the survival of the fittest. In any environment, plants and animals from the same species show natural variation in their physical characteristics, such as neck length in giraffes. Darwin suggested that those plants and animals best suited to their environment are more likely to survive and pass on their characteristics to their offspring. Over a long period of time, the characteristics of the surviving members of the species will come to predominate. Confused? Take the peppered moth. In London in the early 1800s, 98% of peppered moths had light-coloured bodies. Only 2% were dark. The light moths were very happy because they were the same colour as the trees, which meant that they could easily hide from hungry birds. The dark peppered moths were easy to see and, well, eat. Then came the factories and the smoke of the Industrial Revolution. Many trees turned black with soot, and suddenly it was the dark moths who were able to survive better in their environments. By 1895, the dark peppered moths made up 95% of the population. That's quite a turnaround. The process of natural selection usually takes much longer, but this is a good example of how it works. What about us humans? Good question. Darwin went on to suggest that humans share a common ancestor with modern apes.
So the apes.
This was controversial because it went against the religious beliefs of many people.
So again, you can see in the picture here that this person explained so far what was called the evolution theory and by natural selection, which means that over time these certain species of animals kind of develop and fit into their organisms and fit into their surroundings. So let's say an ape, for example, was developed into human. That means apes developed certain functions and certain abilities that make the apes shape like human beings. And that is because of their surroundings and later developed to fit better in the surroundings. So that's what Darwin suggests, that how apes became human beings. By being able to survive better, the apes changed into what is called humans, like us. So that was the evolution theory and their basics. And this video actually shows the basic timeline of what happened.
Try Colgate Total Black Pro Release and be dentist ready.
So 1 minute video of how from a single cell organisms developed into humans. And again, this is just a theory, and a theory means that it is not really certain, but most scientists believe it this way, although it goes against other religions like Christian religions and stuff like that of an existence of God. But I'll show you guys this development in a minute. So it developed into some sort of fish. Okay. And turned into reptiles. dinosaurs, and into other animals, and into monkeys, and to apes, into what is years ago to present as us, humans, which is quite interesting. So just recap here, the universe started with a big bang. Everything started with a big bang, which is the tiny ball that exploded and formed stars and galaxies, and the universe began expanding ever since the Big Bang. And the Big Bang formed billions of galaxies, in which contain stars, planets, rocks, and dusts. And in our galaxy called the Milky Way, we have our solar system. So in our solar system is the Earth, where we live, and the Earth was made around 3.7 billion years ago and was first a hot liquid that was held together by gravity. And first life on Earth began as a microscopic organisms, and organisms began developing and eventually became humans. And again, everything started from the Big Bang, which is the important message of today. I'd like to conclude by watching this video, which is a short 10-minute documentary of how, from the beginning of the universe to present day. It's really interesting, so stay tuned. So every second is 22 million years. 3, 2, Big Bang.
From the primordial cloud of gas and cosmic dust, gravity forged the stars. Gravity connects star systems together in vast galaxies and steers them on their journey through unbounded space.
And I would like to point out the bottom here, increased in years.
The relentless
So the years
flow
are
of time
increasing in
has
millions
driven
of
the
years.
evolution of the
So
universe
keep your eye at
and
the bottom.
created extraordinary wonders. Some galaxies form so close together that they're locked in a gravitational embrace. What a magnificent sight it would be.
It's a galaxy. It's a
As
formation
it
of a
evolves,
galaxy.
the universe passes through distinct eras. Vast ages whose beginnings and endings are marked by unique milestones. The births and deaths of its wonders.
We are the product of a grand evolutionary sequence, cosmic evolution, about which we are only occasionally aware.
Gravity is the great creator, the constructor of worlds. But gravity is also the destroyer, because it's relentless. When a star around 15 times the mass of our Sun collapses, all the matter in its core is crushed into an infinite void of blackness known as a stellar mass black hole.
It's a black hole. It's pulling in the stars.
The immense gravitational pull of these monsters can rip a star apart. They tear matter from its surface and drag it into orbit. This superheated matter spins around the mouth of the black hole, and great jets of radiation fire from the core. Although these jets can be seen across the cosmos, the core itself remains a mystery. Not even light can escape, so their interior is forever hidden from us. Throughout a star's life, there is a constant battle between energy pushing out and gravity pushing in. When it runs out of fuel, the star collapses and then explodes with the brightness of 1 billion suns.
So that's the explosion and the collapse of a sun. And then they rebirth too.
As the star is torn apart, it will fire out into space all the elements that it created in its life and death. These are new stars forming from the elements blown out by supernova explosions. New stars being born from the remains of dead ones. And it's from this universal process of death and rebirth that we emerged. Because it was in a nebula just like this 5 billion years ago that our sun was formed. Clouds of hydrogen collapse further and further under the force of gravity, and the life cycle of a new star has begun. A star was born that would come to be known as the Sun. Around it, a network of planets formed. Among them was the Earth.
It's first just a liquid, like you can see.
Debris left over from the formation of the solar system collides with the Earth. Earth began life as a molten hell.
The early continents were still forming. The land was dominated by volcanoes, hostile and lifeless. But deep in the oceans, life had begun. The latest theory is that chemicals spewing from underwater volcanic vents solidified and created the conditions needed for the first cells to form. For some 3 billion years, simple microscopic organisms were the most advanced form of life on the planet. Cyanobacteria and other oxygen-producing microbes began to bloom. These flourished in colonies of plant-like microbes that pumped out enormous volumes of oxygen. And it was this increase in oxygen that was the key to the rise of the animal kingdom.
Organisms started using oxygen to respire, yielding a lot more energy, which allowed the development of more complex life.
Just before complex life appeared, the world was in the grip of the biggest ice age in its entire history. And then suddenly, advanced organisms appeared.
Developed into the fish. And that was the time lapse of the entire universe from the Big Bang to today. And yeah, I hope you guys enjoyed it. And today's lesson was on Big Bang. So the important takeaway here is that everything started from the Big Bang, and they formed gases, which formed stars, into galaxies. So I hope you guys enjoyed it, and next time we're going to be learning more about the human development. So if you guys have any questions, you can ask them in class, and yeah, I'll see you guys next week. Bye!